Hey Calc, this is section 10.4 in or dealing with trig functions and simplifying trig functions. They give you this table to start with. These are the sum and difference formulas. And also, if you printed out that unit circle that I attached to the Google Classroom, they are right here in this top right corner of the formulas. I want to talk say a few things about these sum and difference formulas. This first one here is the sine formula, sine of u plus v. And what they really want to get at with these formulas here is to say that you cannot use the distributive property when you are dealing with sines of angles or cosines of angles or tangents of angles. So like sine of u plus v, you can't just multiply the sine through and have sine of u plus sine of v. It doesn't really work that way. Oops, sine of v. It doesn't work that way. This sine of u plus v actually comes out to be a lot more involved than just sine of u plus sine of v. So distributive property does not work for any of these. The formulas are a lot more intricate than that. If you look on the unit circle that I have here, instead of writing sine of u plus v as one formula and then sine of u minus v, I've condensed them down into just one formula. So if you're doing sine of u plus v, that's sine of u cosine v plus cosine u sine of v. If you're doing the plus here, you do the plus here. If you're doing the minus here, you do the minus here. Okay. For cosine, if you're doing the plus here, you do the minus here. And if you're doing the minus here, you do the plus here. Okay. For tangent, if you're doing plus here, you do plus here and minus here. And if you're doing minus, you do minus and plus. So that's kind of how that works out. It's like two formulas embedded into one. I do want to say over here on this formula sheet that I have, let's see, I have something mixed around here. One of my formulas for tangent on this sheet is wrong, and it is plus minus and minus plus. This guy should be a plus sign right here. So change that on this sheet if you're going to refer back to this guy. That is a typo. So I apologize for that, but I remember that every year. I wonder I haven't fixed it by now. So, all right, now applying these trig functions and sum and difference formulas. The reason why we do that is to find the exact value of like cosine of 75 degrees. I know you can plug it into your calculator and you can get a decimal, but that's not the exact value we want, like square roots and the exact value. I do not have a 75 degree on my unit circle, but I do have a 30 degree and a 45 degree. So what we're going to do is we're going to write cosine of 75 as cosine of 30 plus 45, or 45 plus 30. It doesn't matter which order you put them in, okay? All right, the formula for cosine of plus is cosine u cosine v minus sine u sine v. So I'm going to use that formula here. When you do split this up into two pieces, this would be like your u and this would be your v. Okay, so I'm going to do cosine of u. That means cosine of 30. Cosine of v, that's cosine of 45. So those two are being multiplied together. And then you do minus sine of 30. Sine of 30 times sine of 45. Okay, and that's the formula. Now I look on the unit circle and cosine of 30. 30 degrees is here. Cosine is the x coordinate. So I have square root of 3 over 2. Square root of 3 over 2 is what this guy is. All right, cosine of 45 degrees is square root of 2 over 2. Okay, we're going to multiply those together here in just a second. All right, minus sine of 30 is the y-coordinate at 30 degrees, so 1/2 times sine of 45 is the y-coordinate at 45 degrees, which is square root of 2 over 2. Okay, now we're going to multiply stuff together. So over here, square root of 3 times square root of 2 is the square root of 6, and 2 times 2 is 4. Then I have minus 1 times the square root of 2 on the top is the square root of 2, and 2 times 2 is 4, like that. Now the square root of 6 minus the square root of 2, I cannot combine those, so I'm just going to leave that as the square root of 6 minus the square root of 2 and put it all over 4, and that's the exact value of the cosine of 75 degrees. Okay, if you plug this into your calculator and get a decimal, and then type in cosine of 75 degrees, you'll get another decimal. Those two decimals should match up. So that's a good way of checking yourself. Figure out what this is as a decimal, figure out what that is as a decimal, and it should be the same. Okay, so use that to check. All right, find the exact value of tangent of pi over 12. This is exactly the same thing as what we did up here, but it's using radians instead of degrees. I can remember McCoy from last year. I know you hated doing these, and you switched every single one of these to degrees. So let's just go ahead and do that because I know that's the way you like it, and so we're gonna cater to McCoy today. All right. So to change from radians to degrees, you might remember from chapter 9, pi over 12. We're gonna do times 180 over pi. The pi's will cancel. 12 and 180, I can divide both of those by 6. Actually, I think I can divide by 12, maybe. Let's divide by 6. So this would be 2, and this would be 30. Yeah, and that would be 15. So 12 must go into 180, 15. 15 degrees. Okay, so this is tangent of 15 degrees is what we're trying to find the exact value of. And again, I don't have a 15 degree on my unit circle. But what I do have is 45 and 30, or I have 60 and 45. So I can do either tangent of 45 minus 30, or I can do tangent of 60 minus 45, or I could do tangent of 135 minus 120. Whichever one of those you want to do, I'm just going to use the smallest ones. I'm going to use 45 and 30 degrees. So let's do tangent of 45 minus 30 is what he looks like. That's what he will break down into. Okay. So what you want to do is this piece right here, you want to write him as 2 degrees that you do know what they are. All right. So tangent of 45 minus 30. This is the minus equation up here. All right. So I'm going to see if I can get this all on one screen. We've got tangent of u, and u is 45. V is my second one. Tangent of 45 minus tangent of 30 over 1 plus tangent of 45 times tangent of 30. That's what the equation up here says. Okay. All right. So let's go through and let's figure out what some of these simplifications are. All right. Let's see if I can get this all on one screen. Okay. Tangent of 45. 45 degrees is this guy right here, and tangent is 1. So I have 1 minus tangent of 30 is square root of 3 over 3. This is going to get to be looking kind of ugly. 1 from here, let's just shift him over, plus tangent of 45 is 1 times square root of 3 over 3. Okay, so there I have that now. All right, now we're dealing with this guy and simplifying him. Again, we don't want to convert any of these to decimals because that's not the exact value. Okay, so what I'm going to do is with this piece right here, I'm going to get a common denominator. 1 is like saying 3 over 3. So I've got on the top 3 minus the square root of 3 all over 3. That's what the top piece is. Okay, and 1 times the square root of 3 over 3 is just the square root of 3 over 3. And I've kind of got the same situation here. If I want to find a common denominator, I've got 3 over 3 plus square root of 3 over 3. So I've got 3 plus the square root of 3 over 3, like this. Okay? All right? And what I'm going to do with this piece is I'm going to keep flip-flip. I'm going to flip this to the top. So I'm multiplying by 3 over 3 plus the square root of 3. And then these 3's across from each other will cancel. This top and this bottom will not cancel with each other because one of them is plus and one of them is minus. So I'm just going to leave my answer like that. 3 minus the square root of 3. And 3 plus the square root of 3. Now, technically you should rationalize that, but that's going to be super ugly. So if you can get it to this point, that's where I'm going to stop because I'm not going to rationalize this square root of 3 in the bottom. That's just gets to be too ugly. So there you go. That's the exact value. Again, a way of checking that is figure this out as a decimal and figure out what tangent of 15 degrees is as a decimal, and you can check those two, and they should match up. Okay, that's a way of checking yourself. All right, they want us to find the exact value of sine of 42, cosine of 12 minus cosine 42 sine of 12. Okay, so that formula is the written out formula, and they want us to kind of condense that. So let's see, what does that come out to be? 42 and 12. Oh, yeah. Okay, I see where they're coming with this. So this is sine, cosine, minus cosine, sine. So I'm looking up here, sine, cosine, minus cosine, sine. That's this one right here. So what that amounts to is sine of u minus v. U is 42 and v is 12. So sine of u minus v is sine of 42 minus 12. Okay, and 42 minus 12 is actually sine of 30 degrees. Well, I know what sine of 30 degrees is. It's the y-coordinate at 30, which is 1/2. There we go. So this one was taking it and putting it back together. Okay. All right. Example 4. Here we go. So an application of a sum formula. So we've got cosine of something plus something. This is going to be like my u, and this is going to be like my v. Okay. So sine of u plus v is what we've got going on here. Sine of u plus v. Or no, excuse me, cosine of u plus v. Cosine of u plus v. Let's see if I can fold this paper here. I should just use the one on my unit circle, but I'm not going to. There we go. Let's see if we can get this to work. There we go. All right. So, u plus v, cosine of u plus v is cosine of u, so cosine of arc tangent of 1. And don't worry about how ugly that is for right now, because it's just going to look funny. Times cosine of v, which is cosine of arc cosine x, and then minus from up here, minus sine of arc tangent of 1 times sine of, sine of arc cosine of x. Okay. I don't think you're going to get something that's this ugly on your homework assignment, but I'll go through this one just to show you what he will look like. Okay. One thing I'm going to do to start with, cosine and arc cosine. Arc cosine means the same thing as cosine to the -1 power, like the inverse cosine. So cosine and arc cosine cancel each other out. So this guy's just left with x. Yay! That's the easy part. But cosine and arc tangent don't cross each other out. Sine and arc tangent don't cross each other out, and sine and arc cosine don't cross each other out. Okay. So what we've got to do is we've got to look at what this piece is right here, arc tangent of 1, and we've got to kind of write out what he looks like. So I'm going to draw a triangle, and it's like a triangle that's based in like the first quadrant. So I've got a triangle in the first quadrant, and I know that tangent of some angle that's right there is 1. Okay. So tangent of some theta is equal to 1. If I would write this out, I would say tangent of theta is equal to 1. So theta is equal to inverse tangent of 1. That's inverse tangent is where they get this guy from. Okay. So tangent is, let's see, opposite over adjacent. Okay. So 1 as a fraction is 1 over 1. So the opposite side is 1 and the adjacent side is 1. So I've got this going on here. If you do the Pythagorean theorem, you'll find out that this hypotenuse side is the square root of 2. Okay, because 1 squared plus 1 squared is 2 and square root of 2. So I've got this going on here. So now that I know what this arc tangent of 1 looks like, they want me to take cosine of that angle. Okay, and cosine of this angle is the adjacent side over the hypotenuse side. So 1 over the square root of 2 is what adjacent over hypotenuse will look like. Okay, so now that I know what arc tangent, what that angle looks like, I do cosine of that angle. So I have 1 over the square root of 2 times x. Okay, I'm going to move that x a little bit closer over here. Times x. Okay, minus, and then I have sine of that arc tangent 1. Okay, so I'm going back to my arc tangent 1 triangle that I have going on here, and they want me to do sine of it. Sine is opposite over hypotenuse, which is 1 over the square root of 2. Okay, same as what cosine would be. Okay, and then the last one I have over here, this is the hardest one. Okay, so this guy's done, is arc cosine of x. That means cosine of some angle theta is equal to x. Ugh. And that's how they get theta equals inverse cosine of x, or arc cosine of x, okay? Again, I'm going to draw my triangle, and here is my angle theta, and if cosine of some angle, cosine of this angle equals x, that means the adjacent over the hypotenuse side is equal to x over 1, okay? So the adjacent side is x, and the hypotenuse side is 1. Ugh. Oh, lordy. Okay. And we want to know sine. We want to know the opposite over the hypotenuse. So I'm going to have to do the Pythagorean theorem, and this one I can't really do in my head. I've got x squared plus, let's call it b squared equals 1 squared. Okay, we're solving for this b right here. All right. So b squared is equal to 1 squared, which is 1 minus x squared. And b is equal to the square root. So b is equal to the square root of 1 minus x squared. Now normally we would say plus and minus because we took the square root, but this is representing a distance, and it's a positive distance. So we do 1 minus x squared, and it's only the positive square root. Okay, so now that we know what arc cosine, what the triangle for arc cosine of x looks like, we want to do sine of that. Okay, sine is opposite over hypotenuse. So I have the square root of 1 minus x squared over 1. Okay, opposite over hypotenuse. And now I'm going to simplify this stuff. So 1 over the square root of 2 times x over 1 is, let's see if I have room here, x over the square root of 2. And then I have minus 1 times the square root of 1 minus x squared is just square root of 1 minus x squared, all over the square root of 2. And if I want to write that together, that is x minus the square root of 1 minus x squared all over the square root of 2. And that, my friends, is the exact value, which is really ugly. But that's all that we can do. Okay? All right, next one. They're proving a cofunction identity. So I know that cosine of pi over 2 minus x is equal to sine of x, but I want to show that, okay? And we always show that by starting with the ugliest side first. So this is a cosine of u minus v. U minus v. So u is pi over 2, and v is x. Okay, the formula for that is, if I go back up, cosine of u minus v. Here it is, this bottom one right here. Okay, cosine of u minus v is cosine of u, which is pi over 2, cosine of v, which is x, plus sine of u, which is pi over 2, times sine of v, which is x. Okay, so we've got this going on here, all right? Okay, now we're just going to simplify whatever we can. So cosine of pi over 2, I can look at that on my unit circle. Cosine is the x coordinate at pi over 2, which is 0. Oh man, 0 times cosine of x. Well, I really don't care what cosine of x is because it crosses out because it's times 0. And then plus sine of pi over 2. Sine of pi over 2 is 1 because that's the y coordinate. Okay, 1 times sine of x. And 0 plus 1 times sine of x is equal to sine of x. And we have it done. Okay? That one was kind of nice. All right, let's look on the back side. See what we've got going on here. Simplify each expression. Okay. We just did a cosine of something minus something. So I'm going to skip part A just to save time. Let's go to part B. Let's go to a tangent. This is tangent of theta minus, or theta plus 3 pi. Oh, lordy. So the equation for, I'm going to use my unit circle for this one. The equation for tangent of something plus something. U is theta, V is 3 pi. Okay. Something plus something is going to be tangent of theta, or tangent of my u, plus tangent of my v, which is 3 pi, over 1 minus tangent of my u, which is theta, tangent of my v, which is 3 pi. Okay, and then we're going to simplify. Okay? All right, tangent of theta. I don't know what theta is. We just leave him as tangent of theta. Okay, tangent theta, we don't know. All right, but I do know tangent of 3 pi. Okay, 3 pi, if I look on my unit circle, 3 pi is exactly the same as what pi is, right? Because it's just a coterminal with pi. Well, tangent of 3 pi would be 0. Oh, that's really nice. Tangent of 3 pi is 0. Okay, so plus 0, okay, over 1 minus tangent of theta, I don't know, but then that is times tangent of 3 pi, which is 0. Okay, now we simplify some stuff. Tangent of theta times 0 goes away. Tangent of theta plus 0 is just tangent of theta, and that's going to be all over 1. So tangent of theta is what that simplifies to be. Okay? All right. Sine of x plus pi over 2. So x is going to be my u, and pi over 2 is going to be my v. And we have sine of u plus v. All right? Sine of u plus v is sine of u cosine of v plus cosine of u sine of v. All right? So we start with sine of u, and u is x. Cosine of v, and v is pi over 2. Plus cosine of u, which is x, and sine of v, which is pi over 2. Okay, now we simplify as much as we can. I don't know what sine of x is, so we leave it. Sine x. Cosine of pi over 2. Cosine of pi over 2 is the x coordinate. Cosine is x. Pi over 2 is 0. All right, so that would be times 0, and that's going to drop that term off, which is kind of nice. Cosine of x, I don't know, but I do know sine of pi over 2. Sine of pi over 2 was 1. Okay, so sine of x times 0 goes away. Cosine of x times 1 is cosine of x, and he is simplified. It could be parentheses, or you don't have to. You do parentheses, but there you go. Okay. Example 7 I'm going to skip. This involves the longhand way of finding a derivative, which is what we did in section 4.1, and I said you would hate that until we got to the shortcut. So I'm going to skip that this problem, but we're going to go down to this one here. Oh, honey, I'm sorry. Okay, all right, let's see what we've got going on here. All right, so we've got a sum and we've got a difference. So let's write this whole thing out. This is going to be u, this is going to be v, and then in this problem, u and v are really kind of the same thing, but one of them is plus and one of them is minus. So, all right, I'm going to do my plus identity first. Plus identity first. Let me see if I can get this. Here we go. Okay, so sine of u plus v. Sine of u plus v is sine of u, and u is x, cosine of v, and and v is pi over 4, plus cosine of x sine of pi over 4. Okay, this entire thing here comes from this piece. Okay, now before we start simplifying, I'm gonna write out what this second piece is. So I'm gonna write out what the difference identity would be. So we have plus. The difference identity will be well, the same thing except minus, okay? So it will be sine of x cosine of pi over 4 minus cosine x sine of pi over 4. Okay. So this part is the same since my u's and v's are the same, but instead of it being plus in between, it's minus in between, okay? And that's all equal to -1, all right? Now you can kind of start seeing that some of the stuff cancels out, like cosine x sine of pi over 4. I'm not even going to simplify that because I have minus cosine x sine pi over 4. So this piece cancels with that entire piece. Yay, that's exciting. Okay, then since I have this piece, and they're exactly the same, that makes 2 of those pieces. So 2 sine of x cosine of pi over 4. Yeah, let's do that. Cosine of pi over 4, and that's equal to -1. Okay. All right, now cosine of pi over 4. Cosine of pi over 4 is square root of 2 over 2. So I'm gonna do this, square root of 2 over 2. Okay. If I take square root of 2 over 2 times 2 from the front, this 2 will cancel with this 2 down here. So I really have like the square root of 2 times sine of x equals -1. Okay. Now I'm going to divide by the square root of 2. All right. So I've got sine of x equals negative 1 over the square root of 2, which is actually equal to, if we rationalize, negative square root of 2 over 2. Okay, so what I'm trying to do is I'm trying to find the places where sine of x is negative square root of 2 over 2 on the interval from 0 to 2 pi. So we're trying to find where sine is negative square root of 2 over 2, and sine is the y-coordinate. So we're looking for the y-coordinate being negative square root of 2 over 2. Right here, 5 pi over 4 is where it occurs, negative square root of 2 over 2. And if I keep going, y-coordinate at 7 pi over 4 is negative square root of 2 over 2. So x is going to be equal to 5 pi over 4, and x is equal to 7 pi over 4. And those are my two answers. Okay, there you go.